Hi, third grade. You should have completed your assignment independently. So if you have not, go ahead and try this yourself and then come back and rewatch this video to check your answers. Your assignment today in your workbook was pages 89 and 90. I'm going to be going over the answers to 89 and 90 in this video. So again, pause this video and try these on your own and see how well you can complete the questions. And then return back to this video to check your answers. Let's get to it. Another look. So we're going to take another look at everything that we talked about in this unit. We've talked a lot about patterns in this unit. This unit was all about patterns. The patterns of multiples of 0, 1, 2, 5, 9, and 10. They all have patterns. And we learned that patterns in multiples of 0, 1, 2, 5, 9, and 10 can help us solve those facts. So we're going to take another look at all of them together and use what we know to solve these problems. How many apples are in 5 baskets with 3 apples each? 5 groups of 3 and 3 groups of 5 both have the same number of items. We know that because that's commutative property. We know all about commutative property when we were working with arrays. We know that when we learn one fact, we are actually learning 2. I call it the 2-for-1 deal. So 5 times 3 is equal to 3 times 5 because they equal the same amount. Looking at these arrays, you see here you have 3 groups of 5, and here you have 5 rows, which is 5 groups of 3. They are equal because each of them have 15 items in them. There are 15 here and 15 here. We know the only difference is that the factors flip-flopped places. Now, factors are allowed to do that in multiplication. We know that no matter the order of factors, the product will be the same. So it says use a pattern to multiply by 5. Well, we know that we see a pattern in all multiples of 5. All multiples of 5, you can use skip counting to solve 5's fact. But also, we notice that in the ones place of all multiples of 5, you will find a 0 and a 5. And that's an indicator that you can usually skip count. You can skip count, not usually, always, skip count to find the product of 3 times 5. So when we see 3 times 5, we can automatically say, oh, I see a factor of 5. That means I can skip count by 5 to find the answer. I know if I skip count up to 3 by 5s, I will receive my product. 5, 10, 15. 3 times 5 equals 15. And we also know, because of commutative property, that 5 times 3 is 15. So it says you can multiply numbers in any order and the product is the same. So that was a quick review on commutative property. So it says use patterns to find each product. So what we're going to do is first identify the pattern. So when you see number 1, it says 7 times 2. We've learned in this unit that when we see 2 as a factor, we know that we can skip count to find the product. Whenever you see 2 as a factor, know you can skip count by 2s to find the product. So we are going to skip count by 2 up to 7, and that will give us the answer to 7 times 2. So we go 2, 4, 6, 8, 10, 12, 14. Notice how the numbers in the ones place are either 0, 2, 4, 6, or 8. Notice out of all of these, multiples of 2 all share that pattern. All multiples of 2 have a 0, 2, 4, 6, 8 in the ones place. So we know that the last number we say in our skip count up to 7 is our answer, 14. We can also check that answer because we know another thing about 2. We know that if we flip-flop this, we would have, or we have 7 groups of 2 here, but we also, if we flip-flop this, we would have 2 groups of 7. So that means we could double 7 and we will get our answer. So if you double 7, you would notice that you will get 14. 10 times 5. We know when we see 5 as a factor, we can skip count to find the answer. You could also skip count by tens, and they're going to show you that in this next problem. Because essentially, 10 times 5 is equal to 5 times 10. And they show you that here in these 2 examples. So let's skip count by 5s in this one. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now, how did I know I was going to skip count by 5s? Well, I looked at the places that they gave me here. I saw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups, 10 spaces. So I know that those 10 spaces represented 10. So that told me they wanted me to skip count by 5. 10 times 5 is 50. 5 times 10. How do I know I'm going to skip count by 10s? Well, look at the places they gave me. Look at how many groups I have here. 1, 2, 3, 4, 5. I have 5 groups. Also, remember when we're reading facts, the first factor tells you how many groups you have. So that's why in this example you saw 5 groups of 10. 10 groups of 5. Because 10 is the first factor here. And here you have 5 groups of 10. So I have 5 places. 1, 2, 3, 4, 5. I'm going to skip count by 10 to get my answer. 10. 20, 30, 40, 50. Now notice how 2 completely different ways to solve this problem, same product. You get the same product. And also notice that all the multiples of 10 here have a 0 in the ones place, and all the multiples of 5 here have either a 5 or 0 in the ones place. Find each product. Can you use a pattern to multiply? Let's practice. 2 times 9. We know multiple ways to solve this. We have our 9s pattern we can use to solve this, and we also see 2 as a factor. When you see 2 as a factor, just double that number. If I double 9, I will get 18. What's another way we could solve that? We could skip count up to 9 by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Multiple ways to solve that one. 5 times 8. Whenever I see 5 as a factor, I know I can skip count by 5s. I'm going to skip count by 5s up to 8 using my fingers. 5, 10, 15, 20, 25, 30, 35, 40. Here's another fact with 2 as a factor. I know all I have to do is double that 3, and that gives me my answer. Nine times 1, that follows the identity property. So that means any number times 1 will be itself. It's like the numbers looking in the mirror. And what do they see? Their own reflection. So 9's looking in the mirror, and what does 9 see? 9 sees itself. 10 times 10. There's multiple ways to solve this. Let's use the tens pattern trick that we know. We know that when we are multiplying by 10, we see 10 as a factor. We can take the other factor and place that as our first part of our product and then just add a 0. In this case, I took that 10, I plopped it in the hundreds and tens place, and then added a 0 to the ones place. All you have to do is take the factor you're multiplying by 10 by, plop it in, and then add a 0 to the ones place, and that will give you your answer. Or you could have skip counted. 0 times 0, that follows the 0 property rule, meaning anything times 0 is 0. So we're moving on to our word problems here, and we have a few strategies. Go ahead and embrace this. I went over this today. We learned the cube strategy. We know we can use the cube strategy to attack a word problem. We don't need to be scared of word problems. No reason. So when I write cubes here, cubes helps me remember that word problem strategy. C stands for circle the numbers you need. U stands for underline the question so you know what you're answering. B stands for box up those clue words that tell you what operations you're going to use. Sometimes these word problems ask us to do multiple things, not just one operation, maybe two. And E stands for evaluate. Always come up with a plan before you solve your problem. And always be sure to check your answers if you know a way. So Cassie has 9 books on her bookshelf and 3 books on her desk. She wants to know how many books she has in all. What operation should she use? Explain. Well, first thing I'm going to do is circle the 9 here and then circle my 3. I know I'm going to need those. And it looks like Cassie has 9 books on her shelf and 3 books on her desk. She wants to know how many books she has in all. What operation should she use? I'm going to underline this. That's my question. And I need to underline explain too because I have to explain myself. So, what am I being asked to do here? Now when I get to box it up, that's what I'm thinking to myself. What operation do I have to use? So it's funny that that's also our question. So what you do is find those clue words. And you also have to think about the problem critically. And we're going to do that when we get to E, evaluate. But for now, let's find some clue action words. So in all is definitely something we need to box up. And how many books she has in all. So that means we need to combine. Now, do we just need to combine 9 and 3 to get our answer? Or do we have equal groups here? We are now evaluating the problem. We know that when we see an all, we know we're combining groups. But here's the big question. Are we combining equal groups? Because if we're not, then we just will be adding. So let's think about this. Cassie has 9 books on her shelf. Okay, they're just books. And 3 books on her desk. Okay, they're just books. So it's asking me to add. I'm just adding here because there's no indication that I have equal groups of anything here. My operation is addition. Because 9 books plus 3 books is how I'm going to get the total number in all. Because it wants me to tell them how many books she has in all. How many books? So I know she has 9 books and 3 books. So I know if I add 9 plus 3, I will get the answer. 9 plus 3 is 12. 9, 10, 11, 12. I just checked my answer. Remember to always check your problem's answers. So notice how I checked my answer by adding on. I went ahead and solved my problem, and then I said 9, 10, 11, 12 to check it. Now, It says explain. I'm not going to write on here how I would explain it. You have to write on your book how you would explain it. How would you explain that? Why did we use addition here and not multiplication? Well, we didn't need multiplication because we don't have equal groups. She needs to find the total number of books in unequal groups here. Now, if we had to find something, if we had 9 books and we were maybe trying to calculate how many pages were in each of those books, and each of those books had 3 pages, then maybe, yeah, we would be multiplying in that case, but not in this case. We're just adding up books here. Now let's look at number 10. Ginger found 3 quarters, 2 dimes, and 3 pennies. How much money did she find? This is a good review on money. So you have 25 cents is how much quarters are worth. And 2 dimes. Dimes are 10 a piece. And 3 pennies. Pennies are 1 a piece. So this is a simple problem where you still can use cubes by circling your numbers. And notice that I needed to underline how much money does she have. That means I have to add how much money did she find, okay? So this is my clue words here. Now, I also need to know how much the money is worth. I have to know that quarters are 25 cents a piece, dimes are 10, and pennies are 9. And then I had to come up and evaluate how I was going to solve this. And as you can see, I decided to solve it by making number sentences. How did you plan to solve this? And then it's time to add it all up because I need to know how much money Ginger found. So I know 25 and 25 is 50. And if I take off that 5 and pretend it's not there, I have 2 10s, right? So if I add 2 10s to 50, I get 70. And then I'm going to add that 5 back on. That's 75. I'm going to go ahead and write 75 here. And then I have 10 plus 10. That's easy. That's 20. And then 1 plus 1 plus 1 is 3. And then I would add all of these together. So 75 plus 20. If I take away that 5 again and pretend it's not there and I just have 70 and I add 2 10s to that, that's 70, 80, 90. Put that 5 back on there. I have 95. 95 plus 3 more. 95, 96, 97, 98. So you should have gotten 98 cents total. Norris wrote the equation 7 times 9 equals 63. Blake wrote the equation 7 times 9 equals 9 times 7. Who wrote a correct equation? Explain. So when you see a question like this, they want to know who wrote the correct equation. Now that doesn't mean that either one of them are necessarily wrong. You have to analyze that and decide yourself. You could decide that both of them are right. When you see a question like that, they're not asking you, they're not telling you that one of those are wrong. You have to decide that. So who wrote the correct equation? Well, both of them did. They both wrote the correct equation. Did you write that too? But why? We have to explain that. This is what we should have underlined. And we would have circled all of these. Why is that the case? Why are both equations correct? Both equations are correct because of commutative property. Because of commutative property. 7 times 9 is absolutely 63. How do we know that? Well, we know that because we know when we multiply by 9s, we can just subtract 1 from the factor we're multiplying 9 with, get that first digit in our tens place, which is 6 here, because 7 minus 1 is 6. And we know that all the products of 9, when we add them together, we get the sum of 9. 6 plus 3 is 9, so that's how we got that 3. Now, that's true. We know that 7 times 9 is 63. And we also know commutative property means we can order the factors in any order and get the same product. So if we take 7 and 9 and we flip-flop them and turn that into 9 times 7, we will still get 63, the 2-for-1 deal, remember. So 7 times 9 equals 9 times 7 because of the commutative property. Number 13, Jana wants to multiply 8 times 5. Explain what tools she could use to help find the answer. Then solve the problem. Well, there's multiple tools she could use. You could have chosen even a few tools to use if you wanted to, because you can use one to solve the problem and you can use one to check your answer. So using cubes, let's make sure we're circling all the right things we need to here. So 8 times 5 is essential. We need to circle that. And those are the only numbers we see. What is this asking us to do? We have to underline it. Explain what tools she would use to help. Now, there's nothing to box up because maybe we box up tools because it's not telling us a specific operation to use, but we know we have to focus on what kind of tools. We know the operation. The operation is multiplying. We are multiplying here. That is a clue that we're going to box that up. We know we're multiplying, okay? We're multiplying and we have to think of tools. So we have 8 times 5. So we could use a number line. We could use an array. We could make an array. That's something we could use to solve this. So what would you choose? Did you say array? You could also use equal groups to solve this. You have to pick a tool. See, that's what the question is asking you to do. Yes, we know that there's a factor of 5 and we can count by 5s. We can skip count by 5s until we get to 8 and get our answer. But you must use a tool for this, for it to be correct. You have to listen to what they're asking for. So you could make an array with 8 rows and 5 columns. 8 rows, 5 columns. I'm going to go ahead and make my 5 columns, get those set up, and I know that straight down I would put my A's. Oh, you know what? I have a better idea that would be a lot faster than this. Since I have my tools here, you're going to have to draw them, but I have my stamper here. So I would go my 5 columns, and now in each column, I know I'm going to have 8 in each. There's 3, 4, 5, 6, 7, woo, and then I'm going to put one up here, 8. Double check. Always recheck your answers. Even as adults, we have to do that. There's always room for a little mistake. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 rows here. 8 rows of 5. Yep. 1, 2, 3, 4, 5. And that will give me my answer, which would be 40. How do I know that? Well, I can skip count, silly. 5, 10, 15, 20, 25, 30, 35, 40. Higher order Thinking time. Mrs. O'Malley is setting up for a party. Each adult will get 2 glasses, and each child will get 1 glass. How many glasses does Mrs. O'Malley need? Show your work. Let's think of cubes. Let's circle our numbers here. Mrs. O'Malley is setting up for a party. That's good to know. Each adult will get 2 glasses, okay? 1 glass. So those are our numbers I'm going to need to know. Here's my question. I'm going to underline my question. How many glasses does Mrs. O'Malley need? I need to know how many of something. How many of something. And here is, I'm going to box up my clue here. Each. You know what each tells me? I have equal groups. What operation am I going to use to solve this problem? Did you say multiplying? Yes, I will have to multiply. But I might have to also do something else. So you need to make sure you read it closely. So looking back at cubes, we're on the evaluation part now. So this is where you have to evaluate. Just don't assume that multiplication is all you have to do. You have to read your question closely. And we know when we see these higher order thinking, we know we have to actually think in that higher power. So Mrs. O'Malley is setting up for a party. Each adult will get 2 glasses. There's another each we messed out. Each child will get 1 glass. Did you catch that the first time? So each adult gets 2 glasses. Each child gets 1 glass. How many glasses does Mrs. O'Malley need? Well, we need to know how many people are coming to her party. Where can we find that information? Did you see what I see? There's a chart here. So whenever you're like, where are the other numbers here? If they each get 2 glasses and each child gets 1 glass, well, how can I multiply without knowing how many groups I have? So here we are, 8 adults, 5 children. So let's solve for the adults first. We know that each adult gets 2 glasses. Each adult gets 2 glasses. We have 8 adults, meaning 8 groups, and each adult gets 2. So we can multiply 8 times 2. And what's 8 times 2? We know when we see 2 as a factor, we can double that 8, and we will get 16. Now let's find out how many children there are. There are 5 children, and each child gets 1 glass. So 5 times 1 is 5 because of the identity property. Anything times 1 is itself. Now are we done? Absolutely not. It says how many glasses does Mrs. O'Malley need? Well, this only tells us how many she needs for adults and children separately. We need to combine those 2 products to get our final answer. So don't always assume it's a simple problem. There are sometimes multiple steps to a problem. In this case, we had 3 steps. We had to find the number of glasses all of the adults received and all of the glasses all the children received, and then combine the 2 in all. So 16 plus 5 is 21. She needs 21 glasses. Remember, whenever you see show your work, you need to show your work or you don't get full credit. So this one's a fun one because it's like a puzzle. So for this one, you have to know what those question marks mean. Those are unknowns. Let's read. Each unknown below represents a factor between 1 and 9. So any of these question marks or unknowns can be a factor of 1 and 9. Draw lines to match each fact on the left with the pattern and its products on the right. Pattern. This whole problem is testing to see if you know the patterns of all of these factors here. They're letting you know that it does not matter what the unknown is. It really doesn't. As long as you know the patterns for these factors, you will be able to match up these questions or these definitions of the patterns to the appropriate example. So anything, it could be 1 times 0, 9 times 0, it could be 5 times 0. It doesn't matter. What's the zero property rule? Well, the zero property rule is that anything times 0 is 0. So which one of these sounds like that pattern? 0 in the ones place. That makes sense. All the multiples of 0 have zeros in a ones place. Let's keep reading though. We don't want to settle until we know for sure. 0 or 5 in the ones place? Not just 0 or 5. Could 0, no, 5, no, not at all. Not for multiples of 0. You won't see a 5, not that. Not this. You wouldn't see a 2, 4, 6, 8 in multiples of 5. The other factor in the ones place. No, you wouldn't take this factor and put it as your product in the ones place. 1 less than the unknown factor in the tens place. Doesn't match up to me. It is the number 1. That's the pattern. And any of these numbers, 0 through 9 times 1, it's asking you, what is the identity rule? Well, we know the identity rule is anything times 1 is itself. So which one explains that? 0 or 5 in the ones place? Not really. Not at all. There's going to be different digits in the ones place for this one. Just 0, 2, 4, 6, 8 in the ones place? The other factor in the ones place. Meaning anything times 1 will be the other factor for the product. That is it. So are you checking your answers? How did you do? This one's a simple one. We know whenever we see 2 as a factor, we could skip count by 2s. Which one shows skip counting by 2s? This one's another easy one. We know how to skip count by 5s. We know we can skip count by 5s when solving any multiplication fact with 5 as a factor. What's that pattern? The pattern is 0 and 5 in the ones place. All multiples of 5 have a 0 or a 5. 5, 10, 15, 20, 25, 30, 35, 40. All of those have a 0 or 5 in the ones place. And that leaves you with our last connection. 1 less than the unknown factor is in the tens place, meaning if this was 6 times 9, for instance, I will take 1 from 6. I know that my first number here in my product in the tens place is going to be 1 less than 6. And that's 5. And I also know that the sum of the 2 digits in my product should equal to 9 because it's a multiple of 9. So what plus 5 equals 9? That's 4. That's to show you that pattern. We are all finished. Go ahead and rewatch this video if you missed something and you need to go back and rework it out. And I will see you early.